Hi my students, we already discussed what is a stereoisomerism and we found that the stereoisomerism can be classified into conformational isomerism and a configurational isomerism. And again the configurational isomerism is classified into two, that is an optical isomerism and the geometrical isomerism. And in the last few videos or in the last few classes we discussed in detail about the geometrical isomerism. From today onwards, we are going to discuss the basic concepts or the detailed study of optical isomerism. So let us see what is the optical isomerism. Before entering into the core part of this optical isomerism, we want to go through certain concepts, small concepts related to this. Okay, first one is the plane polarized light. What is a plane polarized light? We know that ordinary light consists of electromagnetic waves of different wavelength. What is the speciality of an electromagnetic wave? We know that the electromagnetic wavelength consists of both the electric field and magnetic field, which is perpendicular to each other and also perpendicular to the direction of propagation of the wave. If we are passing that ordinary light through a prism, that is a monochromatic light having a single wavelength can be obtained. That is given here. Here I am considering an ordinary light in such a way that the electric field has a different direction, and if it is passing through a Nicol prism, we are getting a plane polarized light. That is, in a plane polarized light, the electric field is of having or oscillating only in the one direction, but in the case of an ordinary light, the electric field is oscillating in different direction. If you are passing such an ordinary light through a Nicol prism, we will obtain a light which is having only one plane or only one direction of electric field. That is called the plane polarized light. That is given here. When a beam of monochromatic light is passed through a Nicol prism, the plane polarized light is formed. So what is plane polarized light? Plane polarized light means the light having electric field only in one direction. That is the plane polarized light. Next term is polarization. What is polarization? Light whose vibrations occur only in one plane is called plane polarized light. In the above figure, we found that this light, the plane polarized light consisting only vibration in only one direction. Okay, that process or that phenomenon is called the polarization. The process in which an ordinary light, when it is passed through a Nicol prism, we are getting a plane polarized light, and that phenomenon is called the polarization. So polarization is a phenomenon of obtaining a plane polarized light. Here it is given as light whose vibration occur in only one plane is called the plane polarized light, and the phenomenon is known as the polarization. Okay. The plane in which vibration occur for plane polarized light is called the plane of polarization. So that is a third concept. What is a plane of polarization? Plane of polarization means the plane in which the vibration, we know that the vibration only taking place in one direction, and that plane is called the plane of polarization. Here you can see the plane of polarization. This is an ordinary light. When it is passes through a Nicol prism, we are obtaining a plane polarized light, and this plane, the plane through which the plane of polarization is seen, is called the plane of polarization. Here another plane is also seen. The plane of polarization is A, B, C and D. That is the plane of polarization. Here you can see another plane R, S, P and Q. That is called the plane of vibration. Anyway, I think it is understood for you what is a plane of polarization. Next term is optical activity. You might have heard this concept in your +2 classes. Okay, what is the optical activity? We know that there are certain substances which have the property in such a way that they can rotate the plane of polarization. That is known as the optical activity, and that substance is said to be called the optically active substances. I will say once again, we know that there are certain substances or the property by virtue of which certain substances rotate the plane of polarization of plane polarized light is known as the optical activity, and such substances are said to be called the optically active substances, or it is otherwise called the optically active. That substance is optically active. If a substance shows the optical activity, then we can say that that is an optically active. If it is not making an optical activity, then we can say that it is optically inactive. Anyway, this optical activity is measured using an instrument that is a polarimeter and reported in terms of specific rotation. That is, the optical activity is measured in a unit or in a way which is called the specific rotation. So, the specific rotation will give the information about the optical activity. Next is the dextrorotatory and levorotatory. We know that the substance which rotate the plane of polarized light to the right are called the dextrorotatory, or which is represented with a D or with a simple plus. And those which rotate the plane of polarized light to the left are called the levorotatory, or it is represented with the letter L or otherwise with a minus sign. Here, as shown here, the dextrorotatory and levorotatory. Here, the ordinary light is passed through a Nicol prism and we are obtaining a plane polarized light, that is called the polarization. That is called the, and if the plane polarized light is again passing through a substance which rotate that plane of polarized light to the right, then it is called the dextrorotatory substance. Then if the plane polarized light is passing through another substance, if it is rotated to the left, then it is called the levorotatory substance. Anyway, the substance is called a dextrorotatory if the plane of polarized light is rotate towards the right side, or then if it is towards other's left side, then it is called the levorotatory substance. Okay, then the next term is specific rotation. Okay, just inform you that the optical activity is measured in terms of the specific rotation. So let us see what is a specific rotation, and it is represented with a alpha. Okay, here this is a plane polarized light and it is having a rotation here, and that is called the alpha, or it shows an optical activity. The angle through which the plane polarized light shift, that is the alpha, or the angle of rotation alpha, depends on certain things. That is, first one is the nature of optically active substance, and then a second one is the temperature, and next is the wavelength of light used and the number of optically active molecules. Next is the concentration of the sample solution that we have taken, and the other is the length of the polarimeter too. Okay, these are the things, or these are the factors that depends on the angle of rotation which is happening to the plane polarized light. We know that the optical activity is expressed in terms of the specific rotation that I have already told you, and it is represented as alpha to prefix a D to 25, which is equal to alpha by C into L, where each term is represented 25, which represent the temperature, where D represent the wavelength of the light. Example, the D line of sodium lamp, or lambda, is equal to 589.6 nanometer. Okay, where C is the concentration of the sample solution that we have taken in gram per milliliter, where L is the length of the cell in decimeter. Then alpha is the observed rotation. So this is a simple representation of the specific rotation, or it gives the full information about the optical activity. Okay, the specific rotation of an optically active substance at a specific temperature and wavelength is defined as the observed rotation in degrees with a plane polarized light is passed through 1 decimeter of the solution of the substance having the concentration of 1 gram per milliliter. Okay, so that is called the specific rotation. Okay, and next we are going to explain the elements of symmetry. what is elements of symmetry? I think it's a new term for you and we will discuss in detail. If a molecule has two or more orientation, we know that a molecule may have different orientation. If a molecule has a two or more orientation that are indistinguishable, it is said to possess symmetry. That means if a molecule having different orientation and one orientation cannot be distinguished from the other orientation, then we can say that they possess a symmetry. And what is symmetry operation? If any operations which when performed on a molecule result in a new orientation which is indistinguishable from the original is called a symmetry operation. I think more explanation is needed for that. What is a symmetry operation? Consider a molecule A. Okay. If that molecule A is showing an orientation and I am saying that orientation is called A1, and after that I am making I am applying any operations or applying certain conditions to that orientation A1. After that the orientation changes into another orientation, that is A2. Once again I will say that consider a molecule capital letter A, and that molecule has one orientation, that is A1, and after that I applied a operation or any condition to that molecule A1, then it changes into, then that orientation changes into a new orientation, that is A2. But if I examine that both orientation, the A1 and A2, I cannot distinguish from each other. That is, it is indistinguishable from the original. Then the operation or the condition that applied to the first orientation which helps to obtain the second orientation which is exactly like that of the first one, then that operation is called the symmetry operation. Okay. I will explain in detail what is a symmetry operation again. Okay. Next, a symmetry element. What is a symmetry element? It is a geometrical entity or it is a geometrical operation such as a plane, line or point with respect to which the symmetry operation is carried out. Here I will explain, or here I will give what all are the symmetry operations and what all are the symmetry elements that can be applied to a orientation. The symmetry elements may consist of the axis or certain axis or mirror plane or center of inversion. And the other one, symmetry operations. The symmetry elements and symmetry operations are different concepts. Symmetry elements consist of certain axis that makes the changes for the for one orientation from that of the other. Next is the mirror plane and other is the center of inversion. But in the case of symmetry operation, more importance is given to that concept. That is not for that is not in your syllabus. Anyway, I will just say what all are the symmetry operations that can be applied to any molecule. First one is the identity operation E, then the proper rotation Cn, the reflection sigma, inversion I, then improper rotation which is represented through a letter Sn. Anyway, symmetry elements, these are nothing but some physical entities such as a line, plane, point, etc. But in the case of the symmetry operations, these are some mechanical operations such as a rotation is applying to that orientation, or reflection is applying to that orientation, or inversion to applying any orientation. Why all these are giving? Just because if you are conducting a rotation or reflection or inversion to any orientation, we are getting in another orientation which is exactly same that of the first one, or it is indistinguishable from the other one. All these operations performed about the symmetry element so that indistinguishable structures are produced. So these are the symmetry elements and the symmetry operations. Anyway, we are explaining what all are the symmetry elements. There are three important symmetry elements or elements of symmetry. First one is plane of symmetry, otherwise called the mirror plane. The second one is the axis of symmetry or proper rotation axis of symmetry. Third one is alternating axis of symmetry, otherwise called the improper rotation axis of symmetry. So these are the important elements of symmetry, and we can see what all are they. First one is plane of symmetry. Okay, before saying the definition, we can see an example. Here this is a molecule. If I am considering a plane here, this is a mirror plane in such a way that the two halves which are mirror images to each other. If I am considering a plane here, I can see that this half is exactly the mirror images of the second half. So such an imaginary plane that divides the molecule to two halves, this is the first half and this is the second half, which are the mirror images of each other, then that symmetry is called the plane of symmetry, or otherwise called the mirror plane. So this is the first example, and this is the second example. Here I am considering the imaginary plane here. If I considering this is a line that divides the molecule, then we are getting the two halves which are mirror images to each other. The same plane is applied here. This is the mirror plane, and for the other molecule, for a long molecule, if you are cutting, if we just cut it here if you are considering a plane here, we will not getting a mirror images of one half to the other. If you are only considering the mirror or the plane here, then only we are getting the first half is exactly the mirror images of the second half. Then we can say that this is the only mirror plane that can be applied to this molecule. Okay, so this is a mirror plane, which is the first one. First half is exactly the mirror images of the second one. In the case of this molecule, if we consider a plane here, what will happen if you are considering a plane like here? The first, it will divide this molecule into two halves. Okay, that if we are cutting the molecule here, we know that we are getting a two halves, but the problem is that this part of this molecule will not be the mirror images of the second part. Why? Just because here the two hydrogen atoms are seen and here the two OH atoms are seen. But so that plane is not considered. But if you are considering a plane here, that is this plane, then we can say that this molecule is cut into three, not two halves. Then the first half is exactly mirror images of the second half. So that is all about the plane of symmetry. It is an imaginary plane. We are imagining a plane that divides the molecule into two equal halves, which are mirror images to each other. Okay. Anyway, the next is the axis of symmetry or proper rotation axis. Here I have given different, I think 2 or 3 definitions for this axis of symmetry. First of all, we can see what all are the definitions that I have given here. It is a line about which rotation of a molecule through a certain angle results in an equivalent configuration. A line is considered and which is undergoing a rotation of a molecule through a certain angles result in an equivalent configuration. Or we can see in another definition, it is an imaginary line passing through an object. So we are considering an imaginary line which is passing through an object. That means a molecule or a molecule, but about which when the object or molecule is rotated at a certain angle, an indistinguishable structure is produced. I will explain once again. I am taking a molecule and I am considering an imaginary line that is passing through that molecule, and after that I am making a rotation, rotated through a certain angles. I am considering an angle 30 degree or 40 degree or any angle, and considering a certain angle, and after rotating that molecule I will get another conformation or another structure in such a way that the first structure and the structure after the rotation are indistinguishable from each other, or indistinguishable structure. Then that line is called the axis of symmetry or the proper rotation axis. That is the second type of definition. Or in another definition is that it is simply a rotation about an axis. We are taking an imaginary axis, or we are taking an axis, and this is simply rotation about an axis which passes through the molecule by an angle 360 divided by n. If it is a n is 2, then we will get as 180. Okay. or 2 pi by n, when repeated n times, the molecule returns to the original rotation. The appearance of the molecule must be exactly the same after the operation. If I am considering a molecule, if I make a rotation to 180 degree, I am getting a second molecule, second operation, which is exactly that of the first one. But in certain cases, we want to rotate in another angle. Anyway, we are making a rotation through an angle. The first conformation or the first orientation and the second orientation will be exactly the same after the operation. We are considering the in this symmetry, we can subdivide it into certain axes of symmetry, that is C2 axis of symmetry, C4 axis of symmetry, then C3, C6, etc. and etc. Each symmetry is explained here with an example. First one is C4 axis of symmetry. Here the form means that Cn 360 degree by n. N is the 4, that is 90 degree. Here I am rotating the molecule. Then what will happen? 90 degrees are rotating. What will happen? If we are not considering here I am given the A, B, C, D for your kind information. Okay. If all these are H, we cannot distinguish the first conformation, first orientation to the second orientation. Here I am given A, B, C, D for only you to know how much the anchors are rotating. Here A, B, C, D, then rotating this molecule through this axis in a 90 degree. After that we will get the orientation like this: A here, B here, C and D. That is, each group is rotating to a 90 degree. If all this group are same, then we can say that the first orientation and the second orientation will be exactly equal or indistinguishable structure. Then this is C4 axis of symmetry. The next is C2 axis. Then you can say what is a C3. So next is C3 axis of symmetry. Then you can say, now you can say what is C3 means. C3 means 360 degree divided by 3, that is 120 degree. That is 120 degree will give. Here I am rotating this molecule in a 120 degree. After that we can see that the molecule will rotate like this. The angle between the two bonds will be 120 degree. Anyway, the two orientation will be indistinguishable from each other. The next is a C2 axis of symmetry, 360 by 2, then that is 180. Then molecule, if A and B is rotated through an angle 180 degree, here it changes into B and A. Here also I am saying that the A and B is only given here for your information. If both the A and B are same hydrogen, then we cannot distinguish the first orientation from that of the second orientation. Okay. Next is C6 axis of symmetry. Anyway, 360 degree by 6, that is 60 degree. Here it is given a orientation. If you are making an orientation, rotating this molecule with a 360 degree, we are getting an orientation which is indistinguishable from the other, that is a C6 axis of symmetry. Anyway, you must thorough with the definition for what is an axis of symmetry, study which is favor for you. This is 3 definition is given, which is easy, you study which is favor for you. Okay. Anyway, you make a clear idea about the axis of symmetry. The next one is alternating axis of symmetry or improper rotation axis. What is alternating axis of symmetry? Here the term itself shows that the rotation is not a proper rotation. It is an improper rotation axis. In order to understand the definition, first of all, you want to go through an example. See this example. This is a molecule that we are considering. This molecule is first operation that we are giving to this molecule is that we are rotating that molecule into 90 degree. What will happen if this molecule is rotated into 90 degree? We know that the molecule will changes. Or the group, not molecule, the groups will changes. CH3 will change, comes to here. The CH3 changes to here, and the H is here, and here the CH3 changes into here, and here the HS changes into here. Anyway, this is a change happens if we rotate the molecule into a 90 degree. After that, we are taking the mirror image of this molecule. We are taking the mirror image of this molecule. What will be the molecule? Anyway, the CH3 will be here, H will be here, CH3 will be again here, H will be here. Again the H comes here, CH3 comes here, CH3 comes here, and the H comes here. Then we can see that this molecule is similar to that of the molecule given here. If we are making a 90-degree rotation here. After that we are taking a reflection. Then we understood that this orientation and the first orientation is indistinguishable from each other, or they are same. That is given here. Now I think it's clear for you. It is a line about which a rotation of a molecule through a certain angle followed by a reflection. First we rotated that molecule to 90 degree, and after that we taken the reflection across a plane perpendicular to it, and it yields an equivalent configuration. That means the new orientation will be exactly same that of the orientation that we have taken first. That is work out here. I think it's clear for you. Okay, one more symmetry as I included here, which is not already said to you. For the next is the center of symmetry or center of inversion. Before entering into the definition, you just go to this diagram or just go to this molecule. Here I am considering a single point, and I am drawing a line in this direction and also in the opposite direction. What is seeing? Consider another line. Here I am taking a point and I drawn a line here, and it touches a group that is H, and after that if I extended that line into the opposite direction, I can touch another atom that is also the same as like that of the other line touches. So what will be the center of symmetry? By considering a point in such a way that if I drawn a line into one direction and also to the other direction, it meets a group or molecule which is exactly the same. Here this line touches the CH3 group here, and here it touches the CH3 group here. If such a point is possible to a molecule, then we can say that symmetry is the center of symmetry. Here this is the center of symmetry. Okay, we can see we can go through what is the definition of the center of symmetry. It is an imaginary point at the center of a molecule through which any straight line can be drawn which meets equal points in equal distance in the opposite direction. So these are the lines that is shown to this molecule which touches the same atoms or same molecules, or which meets the equal point in equal points in equal distance in the opposite direction. Okay, these are the elements of symmetry. I think it's clear for you. If you have any doubt, you can ask me. Okay, so thank you.